So for today's video, we will be talking about inverse function. So in math, when we say inverse, it is also known as antifunction. Inverse is a function that reverses another function. If the function f applied to an input x gives a result of y, then applying its inverse function g to y gives the result of x, and vice versa. Meaning to say, the inverse of a function, to get the inverse of a function, we just simply interchange the position of x and y. So in the function given, x is your input, y is your output. But getting the inverse of that, y now will become your input and x will become your output. That's why f of x is equal to y, g of y is equal to x. They are inverse if and only if the input x with the output y becomes the y input and the output x. They just interchange their role or position. So the inverse function is denoted by f raised to negative 1. It means that this is an inverse of the function f in this case. So to give you an example of how to get the inverse of a function, let's have an example here. So find the inverse of the following. So the given uh, function to us is a set of coordinates. So to get the inverse of this, we simply interchange the x and y position, or the position of x and y will be interchanged. So P inverse is equal to 2, negative 3, negative 1, 0, negative 4, 3, 6, and positive 5. So the inverse of this function is this one. Okay, so it's easy to get the inverse of the set of coordinates. Another example, we have the function whose x's are a, b, c. This is the input or the x values. And 1, 2, 3 are the y values. So to get the inverse of that, simply the inverse will become y is now the x of the inverse and x is now the y of the inverse. So as you can see, all the x's of the inverse becomes 1, 2, 3, and all the output of the inverse becomes ABC. They just interchange their position. How to find the inverse of a linear function? So we have here f of x equal to 5x minus 3. First, we need to change the function into an equation. So to do that, we will just change f of x into y. Since we all know that f of x is equal to y, we only use y if we are dealing with an equation. So y is equal to 5x minus 3. Second step is interchange the x and y position. So y will become x will become y. This is x equal to 5y minus 3. And then we need to solve for y. So to solve for the y, we need to transpose negative 3 on the other side of the equation. This will become positive 3. That's 5y. And we have to make sure that the numerical coefficient of 5 is 1. So we need to divide both sides of the equation by 5 to cancel 5y. Now, 5y divided 5, that's y. Then in this case, it can be rewritten as x plus 5 plus 3 over 5. Or you can simply write this one. So the inverse of the function is x plus 3 over 5. So to write this, we will write f raised to negative 1 is equal to x plus 3 over 5. It means this is an inverse of this function. Another example, how do we find the inverse of a rational function? So first, we need to change this function into an equation. So this will become y is equal to x minus 2 all over 2x plus 3. And then, just like the second step of what we did with our linear equation, we need to change all x's with y and all y with x. So y here will become x, and then x will become y. So y minus 2 over 2y plus 3. And then we need to cross multiply this one. So as you can see, this is x, a whole number or a variable. So we just need to put 1 here. So do the cross multiplication. This is x times 2y plus 3 is equal to 1y minus 2. And then distribute. We have 2xy plus 3x is equal to y minus 2. And then we need to transpose y on the left hand side of the equation and transpose 3x on the right hand side of the equation. So 2xy minus y is equal to negative 3x minus 2. And then we need to factor the left hand side of the equation. So the common factor of 2xy and y is y. So let's just try to solve this one in here. So y 2x minus 1 is equal to negative 3x minus 2. Okay, and then we need, since we're solving for y, we need to divide both sides of the equation by 2x minus 1 so that we can remove the 2x minus 1 where the y uh, lies. So this one will be cancelled. So y is equal to negative 3x minus 2 over 2x minus 1. And then we just have to change y with inverse notation. So f raised to negative 1 of x is equal to negative 3x minus 2 all over 2x minus 1. So this is now the inverse of this rational function. So now we will be talking about verifying inverse. So in this case, you'll be given two functions and you are to identify whether they are inverse of each other. So actually, there are two ways to do that. First, you have to get the inverse of any of the function and simply look whether it became the second function. Or you can do the composite function wherein one of the functions will be an input to the other function. So let's try to use solution 1, our first solution on number 1. So first, we need to pick one function which is f of x in this case. And then we have to get the inverse of this. I'm just going to rewrite this one. Okay, so we have f of x is equal to negative 3x. We just have to get the inverse of f of x. If it became negative x over 3, then they are inverse of each other. You can always choose g of x if you like. So to get the inverse of this, we just have to change f of x by y, negative 3x. Then change the position of x and y. This is negative 3y. And then we need to solve for y. Divide both sides by negative 3. Cancel, cancel. This is, let's just rewrite this one. Y is equal to x over negative 3 or negative x over 3. Okay? So as you can see, the inverse of this became g of x. Therefore, they are inverse of each other. Using solution 2, we can use the composite function wherein f of g of x should be equal to x. So in this case, we will use the composite function wherein g of x will be our input in the function f of x. If the resulting if the result is x, then therefore the two functions are inverse of each other. We can always use f of x as an input of g of x. So in this case, we will just write f of x is equal to negative 3x Then g is equal to negative x over 3. So negative 3, negative x over 3. Simply distribute negative 3. 3 will be cancelled. So negative x over 3. And then distribute negative sign. This will become, I'm sorry, this will be cancelled. This is cancelled already. Alright, so negative times negative x is positive x. So f of negative x over 3 became positive x. Therefore, number 1 is an inverse of each other, proven by two solutions. Next, let's have number 2. So let's try to get the inverse of f of x and check if the inverse is 1/3 x plus 2. So this will become y, 3x plus 6. This will become x, 3y plus 6. And then we need to solve for y. So I'm just gonna rewrite the equation. So transpose positive x on the other side of the equation. This will become negative 6 is equal to 3y. And then we need to divide both sides of the equation by 3. So this will be cancelled. Okay, and this can be rewritten as x over 3 minus 6 over 3 is equal to y. And then we can simplify negative or 6 over 3. This is x over 3 minus 2 is equal to y. And as you can notice, our answer is not equal with g of x. Therefore, they are not inverse of each other unless this minus 2 become positive 2 or plus 2. So, this is inverse. This is not inverse. Next, let's check number 3 if they are inverse of each other using our solution number 2. So, f of g of x. So, f is 2x plus 5. We just put g of x as our input. So, this will become x minus 5 over 2 plus 5. Then simplify by cancelling 2. X minus 5 plus 5. Minus 5 plus 5 is 0. So our answer is x. Therefore, they are inverse of each other because uh, the resulting or the answer that we got with our composite process is x. So thank you so much for listening. That's all about inverse function.